What is going on? Yeah, we're coming online. Here we are. Reset that value. We're live. Welcome to Amber Skies, the future of 3D networking. As we are going to start traveling into the 3D very soon. This microphone's in the wrong place. How's about there? Is that any better? I think that's better. Okay, I know what's going to happen next, so I'm going to do it anyway. Let's open the what code. Well, normally I would go straight to what we're doing today. Today I'm not. I'm going to go straight to Visual Studio Code. There we go. Can anybody see any problems? I can see some problems already. Alrighty. Okay, problems seem fixed, except for one. We've got one. There it goes. It's just updated now. The E was broken. Right. Let's try network. And let's try release. Nothing that good. Debug. Just checking what files I've got in here. Okay. That's fine. There's network. There's the network code. And there's the CPP file. Okay, looks okay. Maybe this thing's hiding again, but there is actually a bug going on here, which may become evident later. I'm not sure how this works. So, first things first, I'm going to say hires to everybody. Hires to everybody, because you're all welcome. And that's changed. So, does anybody know on Twitch? What am I doing? I am... Oh, it's Mr... Oh, right. Mr. Etvenet. ETVNet. Hello, Mr. ETVNet. I'm looking at the colour of my name and thinking, why has it changed in the chat? I don't know what colour you see my name as in the chat. But yesterday morning we had a bug that stopped me from shutting down the program. And last night after finishing my stream, part 2, I sat down and thought about it. I didn't open the program, I didn't look at it or anything like that. I just sat down and thought about why would I have a bug closing down a program. And the only reason is because it can't unwind the stack, which I said during that part 1 episode. And I was right, it couldn't unwind the stack. There's a good reason for it not being able to unwind the stack, because I realised then that there was a problem in the management of an item of data that we had, an address. Who was it owned by? And I think it was Nanocom said, or somebody said, oh, I wish I could remember names, you know, it really would help, but somebody said it's to do with, like, use a smart pointer and everything. And they're quite right. Using a smart pointer would have resolved it immediately. But I wanted to understand why it was happening. And it was happening because we... Oh, that's nice coffee. It's because we, in our program here, we were, upon receiving data, we were assigning the data. Data equals mpacket in data. So we extracted it there as a new uint 8, and we were passing it out, as they correctly said, as an address, which then transferred the ownership of that data, which is all coming from in here, the packet in, which was the thing that was causing the crash, by the way, the SIG fault. And it was taking that and giving ownership over to somebody else. So what we should have done was taken one further step, because I thought by doing this we were extracting the data. We're not. So instead of doing that, we should have set a limit. Now this starts to make sense. We don't need star anymore. Okay? But what's happening here? Ah, so you can't do that, can you? So what we really want there is and 0. Will it allow that? No, it won't. Is it because that's supposed to be a star? No, it's not. Is it because it's supposed to just be data 0? No, it's not. What's going on here? You can't do it, is the answer. It's an address. It's not a data structure, and that's what I didn't realise. So, yeah, okay. We have to go back to a memory address, like that, and everything cleans up again. Don't need to make it new. But what do we do when we receive that? What is the first thing we do upon receiving that data? The first thing we're going to do is extract it. But isn't that what received data should be doing anyway? Yeah, this was all learnt yesterday morning and me thinking about it last night. So we were actually doing the next step after calling receive data. And that was the problem. So we have to now look at MMO server. Somebody's been messing with my files here on MMO server. Who was it? Was it me? Yes, it was. That's good news. Wow, that was a bit awkward. So in here, the reason for it crashing is because we now own it in here. Where do we do it? Incoming, obviously. Receive data from network. Here we go. What do? We do 2 lines. We have the address, and then we take it out of the address. So that is absolutely rubbish. Isn't it? We now own that address. But what we really want is the data. And the data is a number of bytes. What we really want here is the data, literally a copy of the data. So this is what we have to think about, how we're going to get a copy of the data. Where is the data? Look, how do we want to represent our data? Well, it's bytes. What's a good way of storing bytes? Remember, this is C, not C++ now. So, there's the bug. How did I resolve it last night? I didn't actually type it in last night to resolve it, by the way. Because it doesn't matter. As soon as we do it, it's going to break our other stuff. Or any stuff that uses this. We can't do that. We can't just send this data out as an address. We need to send the data. That is what that really says. We are returning the data. But we're not. We're returning the address of the data. That is what we have now. Okay, let's put that back together now. We can capitalise the O. We can capitalise the A. Okay, the address of the data. That is what we are returning. And I think now you can understand the problem. So that's the problem we have to solve. It's a bug. We want the data. We can't do that. We want the data. What form do we want the data in? Now there's only one form that I can think of that's going to be easily doable. And it's funny because it's still going to return data. It's still going to return an address. So there's my thoughts. If anybody's got the solution to that, that's fine. But at least now we've got this glowing red thingy here, and it won't work. So lovely, that will not compile. That is an error. Good. So now we've gone from a bug to an error. That's good. At least now we understand. And the code tells us that we understand, which is fine. So what are we doing today? That's a good question. What am I doing? Oh, yes. You've asked the right question, indeed. Oh, wait a minute. No, I wanted to try something there. I wanted to do this. Close workspace. Thank you. Now close. There's a reason for that. I'm getting a memory allocation error on Visual Studio Code. I could see it when I opened it up previously, but it seems to have tried to have fixed itself and hidden itself again, which is fine. That's fine. What should we do? What should we do? What should we do today? Okay, Windows Defender scan results. Let's have a look at that. Because obviously I had to do a virus check just to make sure that 0 threats were found. So I've done a full virus check of the computer to make sure that somebody yesterday hadn't been tampering with my my system, as I did have a couple of people in chat that were suspect, to say the least. And I've also received an email that's been suspect relating to the channel, which is fine. I don't mind that. Alright, what are we doing? What are we doing? What are we doing? We are... I have this set up because I want to talk about that first. Open file. Current. So that's day 9. We'd done all this and then we broke our program. So all of this has been done except for that shutdown method. That has a bug. Which now has an error, not a bug. So that one's to be looked at. Reflection on what has been learnt, we did that. What has to be done, we did that. Initial thoughts on game state, I think I've really avoided that. And how to manage it. So yeah, I'll give that a tick. That's excellent. Let's load up the next file. Continue. We came up with project structure 1, and then I came up with project structure 2, which was a bit better. So we had data, we had the network, we had the GUI, we had the game server, and we had the output, which is the classic old theme of input, do something, output, which is what every program is. There are other scribblings on here about the 3D object being the .obj, Blender, all coming from there. And the data side here is going to be our game state. And I think that's as far as I really went into game state. So I think that's where we're going to start, because we have to decide upon it. At some point we have to decide upon it, and we already have, is the answer. So it's not that bad. Joel board in case we need it. And we'll just drop you off the screen. Now, I need to reload Visual Studio so we can talk about game state. Has it done it? Yeah, it was a memory allocation error that I had. Visual Studio Code, whoever's making it, you got a memory allocation error, by the way. Doesn't matter, I'm not bothered. There it is. Look at that. So, what does that mean? That means I can't continue using Visual Studio Code as it stands. Interesting. I knew it was going to do it. I just wondered when. Microsoft, Visual Studio Code, where are you? Visual Studio Code, right, here you are. Okay. Oh, right, uninstall. There it is. Whoa, Microsoft Visual Studio Code. Uninstall. Yes. Go away. There was an error. What was that? What happened? Oh, it was successful. Okay. Right, bye-bye. There you go. Right, I no longer have an error when I do Visual Studio Code. Because there isn't any. We can check this. That's how I fix my problems, by the way. I delete them. Why should I use a piece of software that isn't working? Okay. Lovely. Okay. So what have we got? Twitch. Okay. We have. There you go. Our programs are here. Not a problem. I can get to them. But can I write now? Code dot. I can. Error. Not found. Oh. Right, so I can't use Visual Studio Code because I deleted it. Okay, that's fine. There's a way around that. And we just type it in Google. Editing redefined. Here it is. Download for Windows. Stable build. I trust them. I believe them. There it is. VS Code. I haven't got a copy of it, have I? No, I haven't. So, there will do. We'll save. Thank you. Thanks for downloading Visual Studio Code. Ba-bum-bum-bum. So we're now tackling a problem that the editor isn't working. Right, it should be running a test on it now, which I hope it is. There you go, click on that, comes up, click on that, and that comes up. I accept the agreement, and I know what it says because I have actually read it. Not as in the place read it, but I have read the agreement to make sure I'm not going to break it. So we'll put it there. There. Add to path. Register. Add open with code action to... Yeah, okay. Add open code to action. Yeah, okay. Create desktop action. Yeah, okay. La 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 la. So this is what I'm doing today. Do I have any of this weird stuff going on? No. Doesn't look like it. At the moment. Let's position it on the window a little bit better. Bit more up. Okay. And the bottom's too low. Just move you. And the right side's too far. There we go. That's about right. That looks good. So, Twitch Workspace. Hi. There's my code. Right. Where were we up to? Damn good question now. Here are you. Don't need you. Okay. So we were looking at the network and altering the network to do things, and we were going to talk about game state. I'm trying to avoid it like mad, aren't I? Hey, where is our game state, or where should our game state be? Well, I already said it was the data. And the data has test. It doesn't have our game. Oh, yes, it does. It's there. There's our game state. Wow, it's huge. Can I get it all on one page? Yeah, I can do that. This is currently our game state. We can have a user that is ready. We can have a user that has a position, X and Y. And we can have other users who come along and they can declare that they are ready, and they can declare that they have a position X and Y. And of course, there's a user's IP, so that we can send messages. If need be, if that field is filled in, we can send a message to that IP address. So that is the total of our game state. Is that going to stay like that? The answer is no. There are going to be more structures. Many more structures. I can name one already now. And it's called skill. Because we want our user to have a skill. There's going to be one user status, maybe health. User statistics. Strength. Intelligence. There you go. Already I'm picking them out of thin air. We are going to have a large game state, and we are going to have to produce code to maintain the game state, and we're going to place that in the game and the game mechanics. We are not going to be placing it in the GUI, the GUI, although that can affect game state. And we'll have a way of doing it through the GUI because we need administrators. And at that point I have to stop. We have to answer a question, and we have to answer it now. And I'll put it in the game state. Who will be the admin for this system? Is it going to be me, the coder? So let's have a look at the choices we've got. We've got me, the coder. We will have let's see, our help desk. People, maybe. The CEO of our company, In other words, Amber Skies, in this case. Is that how you spell company? Amber Skies isn't a company, so organisation equals Amber Skies in this case. I don't know who you work for or your organisation, so there you go. I'll put mine in. Who else could be the admin for this system? Person who installs it. The end user, maybe. Who? Some doctor somewhere. You can laugh at that one. The rest you can't. We have to decide it here and now. Before we even start building a system, we need to know who is going to be the administrator for this system. And we need to know that because we need to know where to put the administrator rules. And we need to know how the administrator is going to access those rules and what they are going to be able to do to the system. Because that is the first thing that we should be programming. We should be programming for the administrator. They should have a definitive set of things that they can do. A set of instructions, let's say, that they can choose from. As I said, we're building an MMO from scratch, so we may as well do it properly. Oh God, I've got the coffees. Coffee, that's a good idea. That might solve it. Any suggestions from the viewers at this point on who will be the admin? There can be only one administrator. So, that's a plural. So I'll put tab here. No. This is plural. Okay. I'm singular. Will I finish this project as singular? Nope, I probably won't. Other coders will come along and mess with my code. So I, as a coder, am plural. There are more coders than me. Okay. So that's two of them down. CEO of our organisation. Nope, that's the plural. The CEO can be changed at any moment in time. There can be multiple CEOs of an organisation. The person who installs it. Oh, that meets the criteria. So I can't do much about that one, can I? Back up. The end user. We're down to two choices now. Now, in an organisation, you'd choose the person who installs it. You would have a Mr. Tech guy who goes around installing everything on all the machines, and he would be the administrator, and he would be the person that administrates all those machines and does all the fixes when things go wrong. Does he ever work on those machines? Does he ever find out what to do to make the things go wrong? What exactly is he administrating? He is going to administrate what the end user cocks up. And the end user will possibly not be told how they cocked things up, because the administrator may not be able to find out how it happened. Because it might have been some coder's mistake, and that would have been called a bug. Oh. So that's how bugs are made. So the classification of bug is a terminology that's come out of organizations using software where administrators don't know what has caused the problem. And they have invented a name for it, and it's called bug. There are no such things in reality. In reality, they had to administer because the user did something. Now, the user knows what they've done, but they don't know that what they did caused the problem, so they don't know what the bug is. They're not a coder. So they go and call the administrator and say, "Oi, your program isn't working as you specified. Can you fix it for me?" And they just come along and they fix it. And go away quite happy saying, "Oh, I fixed the bug." Well, you haven't. All you did was restart the system and ask them to put the password in again, and it carried on working, so you just left them to it. That's what the administrator does. Right, so there's a problem here. Who administrates the program that we are going to write? If you don't want to have bugs in your system, the end user is the administrator. The person who uses the software on that system is the administrator. Well, that's interesting. That means they can do anything with that program they want. Yes. But hold on. If the end user is the administrator, then all that administration code that we're going to write, well, we can just write it into the normal program so the end user can use it without having to assume the title of administrator. They will automatically have to administrate their own software because they are empowered to do so with the choices that they are given. I've just done somebody out of a job, haven't I? Sorry about that person at that organisation that just got fired. What happens there? There are no bugs. What happens there? It results, and I know because I've seen this happen. Ooh, that was bad. Sorry. Went a different colour on me. Results in something of a unique thing about humans. Humans sat in an office talk to each other. And they say, "Oh, I did that and it crashed. I did that and it crashed. Oh, I did that and it crashed. Is there any way to stop it doing, crashing when you do that?" And the answer is yes, there is. And that's what they devise as non-coders, workers, in an office, sat at the tea point, having a cup of coffee, chatting to each other. They create a workaround. What is this? What am I being binged at? Mobile live dashboard. Somebody streaming and... oh, Twitch. Yeah, what about Twitch? Oh, I've got a message from Twitch. 1 second. Got to look at it. It's important. Let's get my box of mail up. Here it is. Oh my god, VJ Zelinksicat. Zelinksicat, thank you very much. Shout out to you, thank you for following. It is very important to me that people follow the channel. Thank you. I appreciate it. I appreciate it a lot. Right. After being interrupted by my phone, dingling at me, because important things happen when you get dingled at. What should the admin... I'm going to give the administrator his job back. The administrator should go round of these people and ask, so is the system working okay? Oh yeah, the system's working okay. We did have a crash, but we've got a workaround. Oh, says the administrator, you did my job for me, that's fine, and walks away. No, stop. Hold on a minute, you got a workaround? And this happened in real life at I'll call it a civil service organisation that I was working in at the time. And this happened. The administrator came around and said, is everything working okay? I said, oh yeah, we've got a workaround, and walked away. Instead of saying, well, what's your workaround? Oh, we do this, that and the other, and it stops the system from crashing, and the system will then do what we want it to. At no point in time did the administrator, whose job it was to administrate the overall systems, take that workaround, write it up as a formal workaround for the system under a set user case, and give it back to the coders, who were sat 2 departments down within a stone's throw from the person he was talking to. Ooh. And I watched it happen. And I was a programmer, so I knew what was going on. I was a programmer before I joined that institution, and I didn't work in that institution as a programmer. I did at one stage because of the Millennium Bug, but anyway, that had nothing to do with it. That was a byproduct of what I was doing at the time. So what is the person who's called the administrator is not the administrator. The person who is the administrator is the person who collects up from the users, the use cases that fail and the workarounds that solve it. That's the administrator's job. Who's the administrator? The real one. Who's got the real control over the software now? We've given it back to the end user. So the end user really should have the admin's tools. And they should be taught how to use them. Because people think, well, the administrator, you need one because what you need to be able to set up passwords and accounts. Do you? Have you seen me do that so far? Oh, no, you don't. You don't need passwords. You don't need accounts. They can be hacked. That is unsafe information. That is a target for hackers, with a big red dot in the middle saying, come and hack me. You may as well, because it saves you, it stops you from hacking the rest of the system. So come and hack me. I've got all the passwords to the system. Come on. And hackers will. They will take that bait and go and hack. At no point have I made an account. But I am going to make an administrator. And the administrator is the user. Now, how do we define one user from another? Well, we've already done it. We've already programmed that. May as well keep this in here. These are just ramblings. Oops. Ramblings! At least I know that I ramble. About who will be the administrator. God, my typing is rubbish. Ramblings. For God's sake. About who will be administrator. Right, okay, let's get rid of that. Who will be the administrator? The administrator will be... let's pick on the server. It's the easiest one to look at. Okay. The administrator will be... user 1, I guess. The person whose machine it is. And that person is running, here we go. That person is the first person that gets stored into is running now. Case 5 here. First person to get stored in there is the administrator. But hold on, this is a server. We don't know who that's going to be. Yes, we do. We know who it's going to be because we are not going to be contacting outside of our system. So the first person in is the administrator. If somebody contacts us from outside of the system must be already up and running. And to be up and running, somebody must have logged in. Otherwise, it's not up and running. Who's the administrator of the servers out there? Well, the owners of the servers out there, they're the admins. They can decide for themselves. I don't care about them. That's not my problem. My problem is my software. So, for what I have just declared is that for my system to be running and functional, we have to have a user, a first user, logged in here. Initial data, did not put it in here. Oh god. User map add to users, yeah. Didn't do that very well. Alright, we didn't do it on here at all. Okay. Alright, that's fine. But we did it on the client originally, where we set the user equals OK. We should do that here as well. For the broadcast especially. Because at the moment we're only broadcasting the user map. We're actually broadcasting the whole user map here. And the first user, the first person it broadcasts to, by the way, is the administrator, the machine user. The person who set the programs running. So we have to have a way of setting the programs running before and verify that it's running with the user before we can accept outside users, is the answer. And we haven't checked. We haven't checked who logged in. We just put this user's IP, blah blah blah. Do we make a key? Yeah, we make a key. And we just throw them in. We haven't even checked if it's the first person or not. We haven't even flagged them as admin. So yeah, we are going to have to do that. And if there isn't an admin here, and this isn't from this computer, the information coming in isn't from this computer, then it has to be thrown away. This computer is not ready to run. And that's how you do it. You state that the first person logging in has to be from 127.1.1.0 or 1, whatever. Whatever. The local loopback is the only person who can log in at the beginning. after this has been run. Now, obviously I'm going to be testing this on the local loopback. Causes me a bit of a problem as a tester, but hey, I'm quite happy to overcome those. So as long as you know where I'm coming from about security. And if you say, oh, you haven't put any security in any of your programs, yes I have. I put my security in the way I write them. So where shall we start? Is there any place anybody wants me to start from? Nano said, what did he want to do? He wanted to look at relationships between the server and lag time for the user. He was quite interested in that. Well, that's the central server, really. That's the game. That's this. To make that work, we have to get that working properly. Oh. Do we? Yes, we do. Okay. We'll do that then. So, we're back to that. Well, I thought this would come back to that. Okay, so that's what we're doing. We are solving the problem of the pointer. The answer is make a smart pointer. There you go, giving you the answer. Go ahead and do it. Oh, I've got some black bubbly burpee liquid. Come on, this is a Game Programmers Club. It's not about me programming at all. If anybody wants to tell me what the heck to do about this. Let's get some fluids in me. Oh, 46 minutes and we've actually might do some programming. I wasn't expecting to do any today. In fact, I might not be doing anything today. I might just sit here and talk about this function until somebody gives me the answer. Because right now I haven't got one. That's maybe a lie. Maybe I have got one, but it's just not in front of me. Okay. I told you I was going to do this live, so everything that I do to this program is going to be recorded live. And this includes me trying to work out these horrible bits. Workspace here. Okay. Development module 2 was a server. It had source code and it had a network. And in its network it must have had a source file. That one there. Start network. That's an interesting source header file. Okay. Let's pull it up. So, network destructor. Look at that destructor. If users connected. That's a very good destructor, that one. I like that destructor. We might be copying that. Initialize is just start network, which is a function outside that does that for us. Network manager equals network manager. Why do we have a network manager? Stupid idea. Did I program this? Yes. Oh dear. They have an IP. Yeah. Start the server. Blah blah blah. Connections. Blah blah blah. New connection. Look, new connection is actually a function. Wow, what a great idea. I think we might do that. Timeout. Sees disconnect client if they haven't talked to us for a while. Update network. Return M is connected. I love that function. That's a perfect Boolean function. That is a perfect function. That's what all functions should look like. Send data. No, we're looking at receive data. Send client to client now. Here we go, receive data. Well, let's have a look at what we do here. So, we check the sockets. We go through the sockets. If the sockets are ready, we put our command to -1. We then take the clients timeout and update it to stop them being timed out, basically. We have to update their clock. We receive the ID. We scan the buffer for the command. Removed test, okay. And then we use the buffer. Well, we send the buffer off under the command. It's a style, it's a shape, it's a thingy, one of those. It's one of those things. It's one of those set ideas in a set programming practice, and it's called the command style, command something or other. Anyway, yeah. Anyway, what it does is it reacts to the command and sends the buffer through to the correct place, is what that does. So I know what it does. I've seen it often enough. Now, it just sends a buffer off. So what's this magical buffer that can just be sent off? Well, we can figure that out probably by looking at the header file. It is an m_buffer, so the header file will tell us. Let's just pop you over here. So, what magical buffer did we use? There it is. And it was set to a size, buffer size. Where does that buffer size come from? One of these two includes, and I bet it's server systems.h and not well, it could be network manager.h. Let's have a look at that. They're not here. Where are they? Server systems.h and network manager.h. Whoa, those titles. That's part of the command structure. That's part of the command structure. Who's including the buffer size? I'm not loading up the program into an IDE to find out. It might be in here. Let's have a look in there. Nope. So we'll go up one. System commands, here it is. It's got a source file. It's got a header file. Let's have a look in here. Yeah, that's a command file system, so it's not in there. I know where it is now. I think I do. If we go right to the top of module 2, server, we've got server, project, build, source, execute. So it's in the source, it's in here. There are 2 header files here. Server application, I bet. Nope, I haven't done it on this one, have I? No, so I don't know is the answer. Look at the beginning. Server application, my app. Where's server application? It's under source server application.h. Source server application.h. Put you up. System commands is part of the command thingy. Network.h and server system. It's one of these two. I think it's server system.h, which you include in everything. Should be, really. Alright, this is the actual system. So it's got user data, enum for the command, and there it is. Max users, buffers, AFK. So it comes under one header file. This is titled server system. It should really be titled server configuration. That might be a better title, because it's got the game state in there, and it's got the defining bits here. That's your config. That's your config file. So not a lot of that. So yeah, we should really have a server. So we should really have a network system.h, I guess, to contain all of this stuff here. But that wouldn't go here, would it? That's split. That's data. That's the only bit we would put in here. It's the top bit. The actual bit that comes under namespace server would put in data. But you can see what it does. You can see exactly what it does. Interesting. Max buffer size 4096. That's an arbitrary value and was just plucked out of thin air. Okay. And I know that. Okay. So now I know how it's working. Brings us back to the initial. Char m buffer size. Okay, and that's the line I want. The only line I want. And this we have to now start working with. The rest of it I don't care about yet. We'll introduce that as we go. But that's the line that I want here. I want it as the first line possible. Okay. That gives us a problem. I know what the value is, so I can now hash define buffer size. When I copy something from my own work, I never alter it. It alters itself later. There you go, 4K. There we go, so mbuffer now works. We now have a buffer. Let's use it. So, return mbuffer. What is mbuffer? It's a char star. It's a char star. Great, how can we return that? That's interesting. Let's look at... Whoa. I haven't got it in my mind how I'm going to use it, so I think I better keep this thingy open. I think I just dismissed it. What's that one? Yeah, okay. Too many windows open. Development module 2 server, source, network source. I want to keep that one open, please. Thank you. You've brought it back out of the ether for me. Receive data. It's void. Void network receive data takes nothing. It just receives data. It doesn't give anything back, but it will send something out. So when we receive data, we should be storing a copy of that buffer somewhere. Somewhere. It's data. We've just received data. Who's going to be handling our data? Not us. So the person that's calling this is not receiving it. That's interesting. That's very interesting. So maybe that's why we made the mistake. It's because we thought that the person calling it was actually interested in the data that it had. And the answer is, well, yes, it is, but not right now. Doesn't want the data right now, and he doesn't want to do anything with the data right now. It's just doing the operation of receiving data. And we can show that. In the CPP file, thank you. We can show that because if we have a look at our network, remember this is just an SDK. This isn't a program. It's what uses it is a program. And it's being used by the server. And that's what we're trying to program. It's being used here. Oh dear. It isn't being used there. It's being used here. So that should just say receive data. We are then trying to make decisions upon that data. Is that right? Should we be doing it that way? Maybe we just need the message type. So shall we just receive the message type back, which is a uint 8? Because all these case types are going to get destroyed in about 15 minutes as soon as I decide on this. And the answer is yeah, it is. It's only the message type at this level that we are interested in. All of this stuff here is shouting out to me saying, I'm a function. I'm a function, free me, get me out of this switch statement. And we will free it. Okay. Right, so if we invalidate the switch, which is what happens next, we can do that quite easily. We just do that. Edit. That. You'll find why I put line comments later. Alright, that no longer exists. Now let's look at that. Now let's look at what we've got here. We have while is running, receive data from net, drag a message type out of it, carry on and do stuff, check if we're still running, sorry, if we're not running anymore, if we're not supposed to be running anymore, then we continue to get out of the loop, and that's when it started crashing, as soon as we got out of that loop. SDL delay is just there to slow things down because I don't want it happening every millisecond. I want it happening, you know, give me processor a break, will you? No, not later. That is the best way of putting it. Broadcast to all users, that's an actual function of its own. So there's the function start. That's the function. Let's get rid of it. This is how we go through, because I know it's all rubbish code. It does the job, but it's rubbish code. It's all going to get rewritten. Then we do the end timer and end splits. Okay, we have to get this code out of here somehow. So we're going to have to make a dumping ground of some kind. where can we make it? Because this is the application, it shouldn't be doing this. Alright, well, I've got nowhere else to put it except the application, unfortunately, at this point, because we haven't made any other files. So, the first... wait a minute. I've gone one too far there, have I? Have we hit the while loop there? No, that's looking alright, actually. I think we're going to be safe with this. Because I'm going to cut the damn thing out. Because it shouldn't be here. Decide take action on message type. There you go, that's what it does. That's the end of it. Okay. So I'm going to replace all of that code with that one line. No, I didn't mean to do cut. So let's go back and put the code in. There. Came from here. Okay. Broadcast to all users every 20 milliseconds. Broadcast timer. That's already self-explanatory. So we'll just take this lot out. You're going to notice something in a minute. This is called refactoring, by the way, if you don't know what I'm doing. We are going to refactor the code and make it better. That's actually got a title already. By the way, if you're wondering why I put this to the left, it's because I've got code for it. There you go. You can be happy with that. I've got that done. I feel better already. Because one, awful code. Two, I can now see what's going on nearly. So where's our execute application? Ah, here we go. There you go. The while loop goes from there to there. So yeah. Why do I have two lines of code here? Shouldn't it be that? Isn't that what we should have done? I think it is. Because that's not what we've got. That's what we should have programmed, but it's not what we programmed. That's a big squiggly red line. So we now need to take that, and it isn't a uint message type, it's a char. Char? Is it? It's an int. All the message types are ints. Uint, uint8. Yeah, okay, I'll leave it at uint8. So the message type goes from 0 to 120 to 255. So the message type is bound to that those number values by that uint8. So message type is a value between 0 and 255. That's what that line tells me. But it's not giving it me. Okay. But that's what I want. So let's go and do it. I made alterations here. I have mbuffer char, yeah, char. Let's have a look at that mbuffer in more detail. See if we can integrate. See if we can use it in here or not. Mbuffer itself is characters. Okay. So the first thing I've got to do is clear it if I'm going to use it. The address of the data is not really important to me. Do I actually... Sorry, I'll bring it back on screen. Do I actually clear it here? I'm using an mbuffer. Yes, I do. But I do it in the receive function. Is the answer. Let's disconnect. Glad I did this. Send, receive. Here we go. This is receive. Mbuffer size. I didn't do the mem set. Yes, I do. It's there. I'm going to need that. So what we're actually doing is this. Wow. Pop you to one side a minute. We're going to need that. So we'll put that as our first thing, because this is received data. There we go. I've forgotten something there, haven't I? Yeah. It's... Ding. That's the actual thing. That's the way I typed it. So I'm not going to do that. We don't have std mem set. Who's got std mem set? Who does memory? Damn it, I can't remember. Yeah, stuff it. I can't remember. So, C++ std : mem set, please. There we go. So who owns you? C string or IO string? C string. Okay. Okay, that actually makes sense because SDL is C. So C string, there it is. Just hiding in there nicely. Control S. Control S. Works now. We're not going to be returning... Yeah, we are. We're going to be returning a uint 8. So that is now definite. That is now a requirement. Oh, just take the star off. Silly me. Thank you. Oh, we've still got a return. That's a problem. What we can return then is the value from mbuffer0. Alright, we've got our buffer. Copy. Can I put it here? That didn't work. Nope, can't put it there like that. Can't dereference it. Why have I got the address here? The source destination address of an incoming outgoing packet. Interesting. If that's the source, where's the actual packet? That's the address of the packet. It gives us host or port. Why are we receiving this data? Socket and packet in. Okay. I don't want that. I just want... That's the data. We are in the receive data function. So that's the data. It's star data. So I can't dereference that. Okay. Can I do that? Yes, I can. That's a bit awkward. We're passing an address. Still passing an address. Are we going to have to do a loop? Oh god, I can't see chat. Chat, do you want to help? You see, the answer is I want to do mbuffer0 as the return value. But I don't want mbuffer0 to be the only thing I read. Get rid of that. That's distracting. Oh, right, so you were getting some information. What? Why was I getting that information when it's here for the data? That's a bit weird. I was reading two pieces of information here, wasn't I? Okay. UDP network.cpp. Okay. Changes. Where are you? You're in network. Alright. Let's reopen it. I'm just going to put that in again. Alright, so this is the original now. Oh, it's muser IP equals that one. I was changing the wrong line, you see. And that's a global variable. That's fine. That means that that's a global variable that can be used. So mbuffer equals that. No, doesn't. This is annoying because I know that that's the wrong answer. That's the right answer. What do we do with this data? We've got to put it somewhere. See, this brings to me 4. Let's just hack it. Let's hack it first. And then we'll look at what this means. I is less than mpacket in. And that will be length semicolon I++ standard loop. And it's mbuffer I equals that I, and that transfers the data. We only send mbuffer 0 out, but we now have the buffer of data. So the doorbell goes. Lovely. Sticky notes. Go grab yourselves a cup of coffee. I've got the doorbell. Okay, it looks like we have a delay in proceedings. I will pick this up from exactly where I am now later on today, hopefully. But you can see how we are now going to be developing received data. We're only going to be passing back the piece of information that is really needed, but we now have, I'll put it here, need a way to store the rest of the information. That's quite easy to do, actually. We'll hack it first, and then, but that will do it. That will do what we want. We are no longer sending a pointer back, and we are actually sending the piece of information back as a character. So now I know that. That's right. This is now right. Back in the application, that's actually a char. Message type coming back is wrong. God damn it. You're getting a char back, mates. That's what you're getting. That's right. Nearly. Okay. Char receive data. Ding. La 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 la. Char receive data. That's what you're sending back. Yep. Char. That is now correct. It says exactly the same thing, and that is a uint 8, by the way. Uint 8 is a char. Same thing, same difference. Well, actually, no, because it's an int 8, isn't it? It's, can it go negative on a character? Never thought about that, but possibly yes. Check. Check. That's correct now. Application CCP. That's correct now. Yeah, it still says it's a uint 8. Well, it isn't. Stupid. It doesn't go at our speed. It goes at its speed. Come on, I dare you to put a red squiggly line beneath it. Char. And there we go. We can take an action now on the message type, which is a character, which has a value between 0 and 255. There you go. Fantastic. We have solved the problem. We have solved the bug. Yes, it's probably signed. Yeah, I know that. Is there an unassigned char, a U char? But it doesn't really matter because the value that we're giving to it is coming from an unsigned value. So, in effect, it is 0 to 255. Message type value is... well, it's minus 255, isn't it, really? Because I think it is probably signed. I'll check that, but I've got to go now. I've got visitors. So I'm going to check on the char. Thank you for pointing that out. It probably is signed. I'll have to go and find out. And we'll have some fun. I'll have some fun later. I will come back. In the meantime, I just want you to keep digging in there and, well, see what new ideas you can come up with. And, of course, you've got to have fun. That's what it's about. Take care all. Catch you later.